Hey guys, and welcome to this introduction to hash tables. Let's say you're tasked with filling up a new library with books, and you want to do it in such a way so that someone, knowing the title of the book they want to find, can easily locate it in your library. One way you might fill out the library would be to order books alphabetically by title. This seems like a logical way to do it. However, when someone wants to find the book they're looking for, and they know the title, they would have to start by doing some guesswork, pulling out a book on the shelf, and checking the title of that book to figure out where their book might be located. This will take a lot of time. Instead, let's say you developed a really neat little computer program that takes as an input the title of the book, and as an output gives you the exact shelf and slot location for that book. Now, if you loaded your library using this program, all someone would have to do to find a book they're looking for is put their title of the book into the same program, which will then output the corresponding shelf and slot number for that book. This is basically how a hash table works. So in computer science, we could consider a hash table as simply an array, which we can depict as a series of boxes, something like this, although this is much smaller than a hash table would actually be implemented. So in this example, we have 5 indexes in this array. And this is almost like the bookshelf in your library. And then another component of a hash table is the hash function. Hash function would be this neat little computer program that takes as an input the title of a book, or a so-called key, and outputs an integer corresponding to an index in your hash table array. So let's do some examples. So let's say you wanted to store the book Hitchhiker's Guide to the Galaxy, which I'll abbreviate as HGG. So we take the hash function, we put the title Hitchhiker's Guide to the Galaxy in our hash function, and that outputs 42 as an integer. And that corresponds to the 42nd index in our array. So here we'll say it's the 42nd index in the array, and we store Hitchhiker's Guide to the Galaxy there. This is good. Now we can also do it with another book. Let's say we have 1984, and we put that in our hash function, and it gives us 84. So let's say this is the 84th index in the array. In 1984, we'll go in here. And we can keep doing this, filling up our library in this way, so that when someone wants to look up a book, let's say they want to look up Hitchhiker's Guide to the Galaxy, they put the same title into the hash function, they'll get 42, because the hash function is the same thing that you loaded it with, and they'll go right to that slot. Very nice and easy. And this is essentially a constant lookup time. However, you could run into some problems. For instance, let's say we wanted to put an introduction to C programming book, and you put that in your hash function, and it gives you 84 as well. So now we have a problem. This is what's called a collision. The hash function maps 2 separate keys to the same index in our array. Now, there are multiple ways to deal with this. I mean, one way would just be, okay, let's go and put it in the next slot in the array. Let's call this 85, and we put it right here. So now, of course, now it's no longer a constant lookup time, because someone would have to, first they would direct it to 84 slot if they wanted to find this book, and they'll say it's not there, so maybe then they'll have to go to the 85th slot. Or maybe it's in the 86th slot, because there's already a book in the 85th slot. This is obviously not the best way to solve it, but it is one way. Another more popular way to solve this would be to use what's called chaining. So instead of storing the books in this array, each indice in this array then becomes a pointer to a linked list, and the linked list will then contain all the books. So this is the 42nd index in the array, and this is then a pointer to Hitchhiker's Guide to the Galaxy. And the same thing here, 84th index and pointer to 1984. And then in this scenario, what we do with this Intro to C book is just link it off of the 1984. So basically, the efficiency of your hash table is all dependent on how good your hash function is. And there are certain ways to optimize your hash function if you know the data which you want to put in your hash table in advance. So it's a very good way of storing data if you know what you want to do in advance, because then you can tweak your hash function to make sure that it maps all your books, in this case, to different indices in your array. In that case, when a hash function does, in fact, map each book to its own index in the array, and there's no chaining, that's called a perfect hash function. And then the lookup time would be constant for everything, and it would be a super, super efficient way to store data. Except, of course, when you define your hash function, to begin with, you have to define a fixed size array. So that's one of the drawbacks. So in any way to store data, there are always pros and cons, and this is just one very popular method called a hash table.